Hey guys, so welcome back to day 9 of solving the lead code problem. So this is hard category of problem 4 to tapping rainwater. So first understand the question. So what they are asking us is like this is something a block and these are the blocks, okay, and there's a gap of water is filled with. So suppose at night there was a raining and water is stuck into the gaps. We have to find the total amount of water which is stuck in this, okay. So what we don't have to find is max. We don't have to find like this is having the max. We don't have to find the max. We need to find the total, okay. So let's jump into the solution. So this is the solution of very optimized code. I won't be explaining this, okay. First we'll go to the first we'll go to the approach of best, in which we are having the linear space and constant, linear space and linear time complexity. In next video I'll be going to explain the constant space and linear time complexity, okay. That is the best one. And first we'll go the intuition. What you have to think is like I made here the graph. First understand this. So this is something which is 2, this is 1 0, okay. So what I need to find, how much water is there in this. So what I'll do here is I'll run a loop from here, right, left to right, and also from here, from left to right. In just two loops we are going to put the max one. Like here this is 0, okay, and second one this 1, and in 1 and 0 which is maximum, this is 1, and 1 and 2 which is maximum, this is 2, and go on doing this, okay. So here you can see when I go from here, the max I have to put in the array L max, okay. So the 0, first one is 0, then 1, and here what we are having 0 and 1 which is max, so 1 is the max, so I'll put here 1, and then again 2 and 1 which is max, so here 2. Now it will go on continuing this, and from right to left will do the same. So this we created. Now why we are creating this 2? Understand intuitively. Just take a graph of this much, okay. So which is the max here? This is the max 3, okay. So from right to left we are having the 3 max, like you can see here also 3 is the max from right to left, and from left to right which is maximum, it is this, okay. So here you can see I ticked here. So when we come here we need to find something. We have to do like 3 minus 0. How much we get? When we come here we have to find the minimum one. So minimum is 0, and we have to minus with the same because we are iterating one time the whole array, okay. So this is the 0, so we'll minus with 0, we'll get something that 0. Now what we will do, we'll jump to here, this is the 1, and this is also 1 because this is minimum, so 1 minus 1 is also 0 here. Now we'll go to the 0, okay. So 0 is 1 and this is 3. Now I'll take 1 minus 0, so what we got? 1. You'll see, okay, we got 1, but how is this possible? Now the question is, how is this possible? I'll clarify one thing. Like if you're somewhere here, okay, I is here because you're iterating. Now when you come to here you need one thing, the maximum and the minimum. I told the maximum from here to here is 3 and the minimum is something this, because 1 is obviously minimum than 3, okay. So what I'll do, I'll take the minimum one, and this side we are going to minus it with the current. So current is 0, and when we take the smaller one 3 and 1, we will be getting here 1 is the smaller. So what is the answer? 1. Actually this is also 1, but how we are doing, if you don't understand again, so I'll just explain it again. So 3 is the bigger one. If water flows, like suppose this and this, forget all about this in the middle, okay. So this is the maximum, this is the smaller. If water comes here, then what would happen here is we'll just be getting how much the smaller one is. If the water comes to here, then obviously water will go flow from here. then that's not the maximum one. Maximum is what, how, which is the minimum block. Minimum block will contains the maximum water here. If this is the maximum, we have to find the minimum block, because minimum block can have the maximum water. So this is how we are doing. We are finding here the maximum, and from here the minimum. So this is minimum and this is maximum here. Now for this I can easily find it. Like 1 is the minimum. I don't know what is the maximum here, but how much is the maximum? I just want to know is this maximum from this? And 3 is obviously maximum from the array, we can get to know. So what I'll do is I'll just minus it and we'll just get the value. This is how this is working here. So if you think of this much, then you'll get to know this is the maximum 3 and this is the 1. So if you, once again I'll just make you understand into I'll let you get the intuition. Okay, so if the rain is coming and container is empty, then water will be filled where you're having the minimum. Like this is the minimum, so max water can be filled up to minimum, because if it fill up to 3, water will flow from here, the minimum container, so the maximum water can be flow according to the minimum. This is so easy to understand right now. Okay, so we are just considering only the minimum one. So this is the intuition you should get. We just need always the minimum one, which we can get from here, because when we go from here we are actually keeping the max value. So if you're here, then how would we know that what is the maximum before that? Yeah, from the array what we stored. Okay, from the array we can know that yeah, this is minimum. In those this is minimum, and with the current I'll just minus it, I'll get the current one. So if you dry run with yourself, we'll get to know more. I'll just explain the code once. So this is how the code is. So my code is actually the optimized one. Okay, so I'll go with the best approach first. So in this video only best approach will be getting. In next video I'll probably uploading the best approach. Sorry, in next video I'll be approaching the optimal approach. So here just see this, okay, question, and this is the height. Okay, we made 2 arrays, left max, right max. Now what is there? We'll run one loop in which we will store the maximum of this and the height. Okay, and in this loop we'll run the loop from the backward. Okay, here you'll ask why n-2. It is just because if we are in boundary, then obviously water will come and it will flow the other side, so we are not including that -2. Okay, so now this will store the right max. Now what I'll do, I'll just compare it and I'll plus in the water and I'll just return the water. This is so simple code. Okay, so I hope you understand this code. In next video I'll be bringing for you the optimized version of this code, in which the space complexity will be constant and the time complexity will be linear. The time complexity will be linear. So thank you for watching. Meet you in the next video. Bye.